Oh, hey there, neighbor. Or I should be saying K nearest neighbor. After expanding your reach with linear regression in last week's episode, we now dive into the intricacies of KNN that empower us to take the next steps in machine learning. This is our next phase, and with talking about regression, we are now looking into classification. Welcome back, guys, to another episode of PyPod Chronicles. Last episode we looked at regression, and we can use regression to make predictions, right? So think about predicting the stock market or housing prices. That's linear regression. Now, another model area I've been finding rather interesting is classification. This relates to us as people, as humans, much more than you think. And in today's episode, I'm here to show you how. Welcome to PyPod Chronicles, a series that brings our tech blog to life in a whole new way. Covering an array of topics surrounding Python and tech, from programming tips, best practices, and so much more. Let's get immersed in Python with the Nerd Nook on the go. You guys, before I dive into the full episode of PyPod Chronicles, the first link in the description, oh my lord, there are so many resources for you guys. I have just dropped 2 full-length free courses, over 30 hours of free content taking you from zero all the way to knowing Python, as well as a boatload of other free resources like a weekly newsletter, this podcast, and resources. Head down to the link in the description and check those out. Show some love if you're listening here. Hit the like button, hit the restack. Comment and let me know, because engagement, right, that really helps keep this podcast alive. We need to understand the essence of KNN, and at its heart, this algorithm works on a fundamental principle. That principle being birds of a feather flock together. Similar things tend to group together. Okay, it's a simple step. Right? If you boil it down, right, like think about, I don't know, your high school days, right? It was a clique. Everyone joins a clique. They have their little friend group. This approach involves classifying data points by looking at a majority class among their closest neighbors, their closest other data points. And unlike parametric models, KNN doesn't rely on specific parameters, which makes it adaptable across different areas. That's kind of cool. Now, we need to explore the mechanics, right? So roll up your sleeves, because I'm about to dive in. How do we classify data? What principles govern the data-making decision? Well, let's answer these. Get ready, grab a cup of coffee, guys. It is, for me, it's 6:30 a.m. Not even kidding. So I am pounding on my coffee right now, and whatever time it is for you, I hope you got some caffeine in your system. If you think about it on a deeper level, this is how KNN and classification relates to us as humans in psychology. Now, this is my analogy, but it works. We as humans are basically a walking example of KNN. Psychologists say that we are a combination of the 5 people that we spend the most time with, right? So these 5 people influence our personality, the way we view the world, our decision-making process, right? That could be, depending on your age, let's use a kid who's at home still, right? The people who influence this kid are most likely the parents, a sibling, and then maybe 2 friends or 2 other important figures in their life. And this child is going to be shaped to a combination of those 5 people. Now, this means that those 5 people affect us, so we're basically gathering data from our 5 closest people in our life. And we're using this data to go through our life and create new informed decisions. Right? Now, this will inevitably change along the way, but that's my analogy. That works for going through life. Okay. If we look at it, a few episodes ago, I gave a flashcard analogy. All right. And I really like my analogy. I'm going to break this down a bit further. All right. Let's say like you're trying to watch a movie. Which movie do you want to watch first on Netflix? And we can think of KNN as like your super smart friend or your creepy friend. That depends on your perspective. Who knows your movie preferences inside and out. Once again, that's a bit creepy. They live next door to you, also not creepy. And whenever you're stuck on what to watch, they pop over to your house for suggestions. Also completely normal. In some places, this would be considered stalking. Well, not here. Here it's considered machine learning. Let me break it down. Right, so neighbor knows best. KNN, it's like asking your closest neighbor for recommendations because they know your taste better than anyone else. Imagine you have a bunch of movies lined up, each one with its own genre and style. You're trying to decide which one to start with. Your friend, the algorithm, looks at your movie collection and picks out the one that's most similar to what movies you've enjoyed in the past. Right? Now, actually, this is literally what Netflix and Spotify does, right? So that's really what happens. Netflix uses the shows that you previously watched to make you a recommendations playlist, right? Spotify creates that weekly Discover Weekly playlist. They take what you've listened to that past week and they try and find other music that closely relates to that. To quickly create an algorithm, the excitement brews now. Make sure, okay, we've talked about this in depth, your data pre-processing step. Okay, at this point, I have clean data. I'm starting with clean data. Okay. Now, if you just want to play around with this, if you tap into Scikit-learn, you can load the iris dataset. And honestly, like when you're just experimenting and you're getting like, oh, this does this, that does that, right? This is great. Okay. It's just a dataset that comes from Scikit-learn. You can use it to just practice with. Okay. And then we want to make sure you pre-process, you clean your data. So train, test, split. We use standard scalar to fit transform to data clean. If you guys missed that episode, guys, the link in the description, head on down and check that out. That was our data pre-processing episode. Now it comes down to choosing the optimal value of K. Selecting the optimal value of K is pivotal in the performance of our KNN algorithm. The choice of K significantly influences the model's ability to generalize to any unseen data. Okay, so to find the most suitable K value, I didn't know this in the get-go, but there's actually a class called getSearchCV. And getSearchCV facilitates an exhaustive search over a specified parameter grid. This really enables you to evaluate the model's performance across various K values through cross-validation. And this process involves splitting the training data into multiple subsets, training the model on different combinations of these hyperparameters, and then selecting the set that yields the best performance. So you're basically testing before testing. It's like a pre-test to a test. Or a pre-test to training your model. Once you've identified the optimal value of K through this grid search algorithm, the next crucial step involves the training of your model using the designated data set and evaluating its performance. This process ensures that our model can generalize well to unseen data and accurately, or attempt to accurately, classify or regress based on these features. So in order to do this right, coming from last episode, we imported linear regression. I used that as a class to create a model. This time it's pretty much the same thing. I'm going to import something called KNeighbors classifier. That is a class. I'm going to use that to create a model object. And inside this class, I'm going to give it the argument of n neighbors, giving it our optimal K value. Now that I have my model, right, we can fit our model. We can apply our training data. After training the KNN model, it's imperative to assess its performance on unseen data and gauge how effective this was. So we typically use an evaluation metrics like accuracy, precision, recall. In my example here on the code, which you can't see, right, the link in the description has the article for this. I'm using the score method and I'm attempting to link that to my model classifier. This method will calculate the accuracy of my KNN model on the test dataset, so test scaled and y-test. The accuracy metric quantifies the proportion of correctly classified instances out of the total number of instances in the test set. All right, very quickly, the when and why. Why use KNN? Well, it's flexible in different scenarios. It's versatility in classification tasks. When to use it? Well, typically with smaller to medium-sized data sets. This is where it really shines. It doesn't handle complex stuff too well, and it also handles nonlinear data distributions. So in situations where data exhibits nonlinear relationships, this is good. Now, advantages, rapid fire, simplicity, nonlinear, adaptability, and interpretability. Okay, but there are disadvantages because it's computational complexity, right? You can't give it big data sets. That's an issue. If you have any outliers in your data, cut them off because KNN is not going to handle the outliers well. So guys, let's really wrap up this episode, all right? The advent of K-nearest neighbor, it revolutionizes the landscape of machine learning, offering a framework for classification, and it also works with regression tasks, a bit more advanced, but yeah, classification and regression. In today's episode, we unraveled the intricacies of KNN. This empowers you and me to really take machine learning to another level. Okay. As we've been exploring some rather advanced topics the last few episodes, I would love to take a step back. And over the next few episodes, I really want to go into key concepts of Python again, because that's why I got started in the first place. All right. So I'm really looking forward to that. Guys, if you enjoyed today's episode, let me know. Okay. Give it a like, give it a restack. I'm not sure where you're hearing this. Apple, Spotify, Substack, YouTube, right? Show some love, engage, ask questions, right? And remember, you can get my free course, absolutely free, with all these other resources. It's the first link in the description. Well, guys, for a 6:30 a.m. podcast, that wasn't so bad. Well, that wraps it up. I will see you guys in next week's episode of PyPod Chronicles. Until then.